Okay, let's solve some questions. Let's call it this. Problems. On AC circuit containing only resistors. So we have example 3 or example 1 in this case. An AC circuit containing a resistor or resistance 3 ohms has an RMS value of current okay, let's see, 250 ohms. RMS value of the current is 5 ampere. Find 1, the RMS value of the voltage. The peak value of the voltage. And then 3, the amount of heat produced in the resistor. So here we have an AC circuit containing a resistor of resistance 250 ohms has an RMS value of current 5 ampere. Find number 1, the RMS value of the voltage. 2, the peak value of the voltage. 3, the amount of heat produced in the resistor. Okay, so here we have here we have the first one. First of all, what are the things given to us? So the resistance is 250 ohms. We have the IRMS will give us 5 ampere. Then the RMS value of the voltage is unknown. We also have peak voltage is unknown. And then the amount of heat produced in the resistor is also unknown. These are the things we have to find. So to answer the first question, we should find the RMS value of the voltage. And you know, from the equation I gave you earlier, we have IRMS. When you apply the Ohm's law to describe the relationship between the voltage and the current in an AC circuit, we have something like this. IRMS is equal to VRMS. There's a root mean square value of the current and a root mean square value of the voltage. We're going to have something like this, you see. So what is and this means we have IRMS. What is IRMS? That's 5 is equal to VRMS, we don't know, all over 250. Okay, if you multiply this by this, 5 times 0 is 0. 5 times 5, 25. 5 times 2, 10, plus 2, 120 volts. So this is the RMS value of the voltage. When you apply this, you're going to get this as your answer. Now, the second question. Find the peak value of the voltage. Now remember, the relationship between the peak and RMS values of voltage and also current too is something like the peak value V naught is equal to 1.414 times 1250 volts. You see? And if you do that calculation, we're going to have something like this. Yes, we have a 1000 V naught. The peak is a 1767.5 volts. So if you multiply these two, this is what you get. And it kind of makes sense because, you know, we said the peak value of current and also voltage is the maximum displacement from the horizontal axis. So if you plot the value of this voltage and also current too, it's pretty much the same thing. It goes like this, you see. So the RMS value is now the thing is this: the RMS value of voltage and current are always smaller than the peak values. Why? Because the RMS values means the root mean square. So you get all the values of the voltage across the side, and then you find the root mean square. You find the mean, then you square it. You get this. So it's always smaller than the peak, which corresponds to the amplitude. You see. So if you're solving this kind of question and you get to a point, or you get the result you get for the RMS and the peak value of the current or voltage is such that the peak is smaller than the RMS value, then no, you're wrong, because the RMS value is always smaller than the peak value. You see, the RMS value is always smaller than the peak value. Now let's go to the third one, number 3. Now this is how we should find the amount of heat produced in the resistor. Now heat produced, electrical heat is given us what? IVT. And you know, I told you that the RMS value of the current is effective, or the one that produces the heat in the resistor or in the resistance. You see, so the current we mean here and the voltage we mean here, obviously the RMS value, not the peak this time. So we have the heat produced would be what is the RMS value of the current? We have 5 multiplied by 1767.5 volts. Of course, time wasn't given to us. Okay, I think I should have, after let's say 3 minutes. Now 3 minutes is the same thing as 3 times 60, because we have 60 seconds in 1 minute, so 3 minutes is going to contain 3 60 seconds. So when you do this multiplication, the heat produced should be multiplied by 5 multiplied by 180, and that gives us something like 1.590750 joules. And of course, if we are going to express this one in kilojoules, this is going to give us 1590.75 kilojoules. See. So this is the amount of heat produced in the entire thing. If there is any question, you let me know. But first of all, before we go on, I would like to recap what we've done. So here we said problems on AC circuits containing only resistors. So here we have an example. An AC circuit containing a resistor of resistance 250 ohms has an RMS value of current 5 ampere. Find 1, the RMS value of the voltage, 2, the peak value of the voltage, 3, the amount of heat produced in the resistor after 3 minutes. So of course these are all the quantities given to you in the question, and the things you were asked to look for are 1, RMS value of voltage, peak value of the voltage, and the amount of heat produced. So to answer the first one, we use the relationship, I think equation 6 we derived earlier. IRMS equals V RMS over R. And if you do that, substitute all the values for the symbols. Yeah, you get V RMS is equal to 1250 volts. The same thing for the current, the peak value of the voltage. And like I told you, the RMS value of the voltage is always smaller than the peak value of the voltage. And that's because the RMS value is just the sum total of all the voltages here, and then you find the mean square, or whatever that is. You see? Which is why it's always smaller. And it is the effective value of the voltage in the circuit. While the peak value is the maximum recorded in the circuit. Now to find the heat produced in the resistor, we have electrical heat is equal to IVT. So H is equal to the ampere, the RMS value of the current is 5. Then the RMS value of the voltage is, the RMS value of the voltage is not this. I just made a mistake. So it is 1250. So this figure here is not correct, but I'm sure you know what exactly I'm talking. When you multiply this and this and this, of course you should get the value of the heat produced. So here we have 5 times 1250 times 180, and that gives us 1,000,000. H now gives us 125,000 joules, or H is equal to 1,125 kilojoules. Any one of them is fine. You see? So if you have any question, just let me know in the comment.